come into my bedroom, come in at night. You'll take your bow away, I'm gonna skin it alive. Where, hold it now, love, you're gonna get cut. Where, hold it down, love, didn't know for what.
So this is Computer Science 2. Officially, this is ECEN 156. And my name is Chris Burke. You can just go ahead and call me Burke. That's fine. There are too many Chris's. I've never been called my first name anyway. And today we're going to give a course introduction, an overview. Everybody's here. There are only 7 enrolled in this course. And then we'll get started, right? So again, a course overview, what this course is about, the course schedule. Just a second, let me make sure. Yep, okay, good, we're good. I'm just checking every day I'll check the audio because this is being live streamed on YouTube. And the recordings will be available immediately afterwards. So if you ever miss anything because of sickness or an event or something like that, you can always watch the live stream or watch the recording. Anyway, we're going to give the course schedule and then the project, because this is a project-based course, what that entails, and then we'll discuss some more resources here. So the mantra of this course is basically a continuation of Computer Science 1. Everybody would have taken that last semester or at some point. But at the end of Computer Science 1, you should be able to approach a reasonably complex problem, design a top-down solution. That is, you're taking that big problem and you're breaking it up into smaller and smaller parts until this is a function that's built in already, or that's a function that I need to write. And then you solve that problem, right? You're able to translate that into a high-level programming language. The key realizations that you should have coming out of Computer Science 1 are that computers and programs that you write are not problem solvers. You're still the problem solver. And computers are dumb, right? Even the AI that we supposedly have right now, it can only regurgitate what it's been trained on, right? They do exactly what they're told to do. There are no ghosts in the machines, right? Programs only automate solutions. Computers are good at processing large amounts of data quickly. Humans are not, right? But computers are bad at formulating solutions. And humans are good at that, right? And so here's a quote by, I think that this was Douglas, no, not Douglas Adams, Michael Crichton, I think. No, this is Douglas Adams. By the time that you've sorted out a complicated idea into little steps that even a stupid machine can deal with, you've certainly learned something about it yourself. So that's what problem solving is in Computer Science 1. By the end of this course, you should be asking your different questions. You should be inverting all of that. You should be able to approach a reasonably complex solution and ask design questions first. What entities or objects should I design to model this problem? How do these objects interact with each other, right? And what data structures can I just pull off the shelf to make this problem solved immediately, right? Can I pull a list or a map or a hash table off of the shelf and then just put stuff in, take stuff out, and I've solved the sorting problem, right? Fundamentally, it's different problem solving approach. It's a bottom-up approach where you are doing the little tiny things first, the details first, and then combining them for an overall solution. If you want a quote that distills my CS2 course down into one quote, it'd be this quote. I forget who it is at this point, but smart data structures and dumb code are a lot better than the other way around, right? So in Computer Science 1, you might have written really, really clever code, really, really smart code, and not used any data structures. You're going to flip that around now. You're going to use data structures so you don't have to write code. You're going to write dumb code. Put stuff in, take stuff out. That's called heap sort, and that's something that we'll talk about by the end. You just use a smart data structure called a heap. You put everything into it, you take everything out of it, and guess what? It's sorted, right? So just 2 lines of code. Put stuff in, take stuff out, and you're done, right? Here's our approximate schedule, whether or not you covered C or Python or MATLAB or whatever. We're going to do another programming language, Java. And if you already have Java experience, that's fine. If you don't have Java experience, that's fine too. We're going to start from the scratch today. Right? Then we'll talk about object-oriented programming in the context of Java. We'll take 2 or 3 weeks on that. Then we'll start doing databases and database design and SQL, or structured query language. So you'll get another programming language out of this. Right? And then about the halfway point or thereabouts after spring break, we'll get into data structures and algorithms. List data structures, algorithms, algorithm analysis, searching and sorting, stacks, queues, and binary search trees, and at the very end, heaps. Okay? Two things are going to be important for grading. In fact, there are no exams, there are no quizzes, there's nothing like that. There are labs and assignments, right? So the labs, there are 14 of those, they're weekly, okay? It's about 20% of your grade. We give you starter code that you have to clone from GitHub, and then you walk through the lab and you finish up that code, and then you ultimately turn it in. We'll talk about that in a second here. This one is a little weird because we have 2 lab sessions on Tuesdays and Thursdays immediately following the lecture. And the reason for that is in the main section in Lincoln, there are actually 2-hour lab sessions, but they can't do that on the UNO campus because of room scheduling, so they split it up into 2 days, okay? It can all be completed asynchronously. In fact, I sent out a note if you've already started on Lab 1 and you've already completed Lab 1, great, right? You can start on Lab 2 for next week if you want to. You can complete them before the lab sessions, after the lab sessions, whatever. But they are due on Thursday by midnight, right? So that's the final deadline. You can't work on them after that, right? The grade is based on completion. As you'll see in today's lab, we will give you a bunch of JUnit tests. Those are unit tests, right? And all you do is press a button and it runs all these tests against the code that you wrote, and it says, this test passes, fails. Oh, it failed. Go back, fix it, right? Once you've got it all running, once you've got all of the test cases passing, you hand it in, you earn your 20 out of 20 points. If one test case passes, that means it's not complete. And so in other words, it's based on completion, okay? So 0 or 20. There's also attendance points required for that. So if you show up to lab on Tuesdays and Thursdays, both of them, I will give you your 5 points, which comes out to about 5% of your overall grade or something like that, 4% of your overall grade. Not a lot, but it's an incentive to come. This is a new policy that I adopted this year because, well, frankly, last year, only 50% even showed up on the first day to lecture at all, right? And guess what the passing rate was? About 50%, right? So, but I do have a resolution for this. If you are not able to come to lab sessions, fine, because of work or you were sick that day or something, you'll get 0 for your, you won't get that 5 points, but if you get 20 out of 20 in your lab by Thursday, then I'll give you those 5 points back, right? So if you can complete it asynchronously and on your own, fine, you don't need to show up. Prove it though, right? I would highly recommend that you come to class and you come to all of the lab sessions at least for the first few weeks, right? Because that's also your opportunity to get help on the assignments, on the homework. Right? The assignments are 80% of your grade. Like I said, there are no exams, no quizzes or anything like that, no pop quizzes or anything. There are about 8 assignments. I start numbering at 0. Why? Because this is computer science. Where do we start counting? Right? We start counting at 0. Right? The first one had 3 basic programs in Java. Everybody should complete these on their own, no collaboration, no partners. Basically, you need to prove to yourself that, yes, I'm ready for this course because I can program. If you can take these 3 problems and program in Python, if that's what you know, or you can program in C, if that's what you know, fine, great, you are ready for this course. But now you're gonna do it in Java over the next 3 weeks. This assignment 0 is due 3 weeks from now, so whatever 3 Fridays from now is. I don't know, it's in Canvas. We'll look at it in a second. Otherwise, all the subsequent assignments are project-based. You will be going through several phases. The first phase of your project, you'll be doing basic object design and EDI, which is electronic data interchange. We give you a bunch of CSV files, comma-separated value files. You read them in from the file into the objects that you design. You dump them out to either JSON or XML, right? This will all be in the handouts. In the second phase, right, so this would be like 6 weeks from now, is your application design and testing. You're going to be writing your own unit tests and JUnit and stuff like that. Then the application implementation. Then you'll design a database to support this application. You'll load data instead of from that CSV file. You'll load it from a database. You'll save back to your database. And then finally, you'll incorporate a list-based data structure into your project. So in other words, 7 phases of a project, right? They build on each other. So make sure that you do a good job in phase 1, because if you don't do a good job in phase 1, you're kind of screwed for phase 2, right? Because you're going to be doing what we call eating your own dog food. If you have a bad design on phase 1, you're going to have to fight that design or work with that design, right? For that reason, we introduce the notion of a design document. Right? You probably have not. So this is this is a project-based, multi-phase themed project. But to go along with that is the design document. It's due 1 week prior to each one of those assignments. Basically, you're going to tell us how you're going to design those classes, how you're going to design that database. Right? It's just going to be an outline. This is why these are called drafts. Right? We'll talk about technical writing like in week 4 or so. Usually I ask somebody from the Writing Center to come in. I don't know if I can do that this year. They didn't come last year, so I don't know if I can get them to do it this year. But we'll talk about how writing for design, technical writing, is different than your 5-paragraph essay, or if you took a poetry class or something like that, right? It's not English, right? In fact, we want it to be short. We want it to be succinct. We want it to be technical, right? And those drafts are part of your grade, right? We will give you, yes, this is a good draft. We will give you all the points on it, right? Because you told us what you're going to design, and we're going to critique it. No, that's a bad design because this reason. Or that's a good design, go with that. Or whatever, right? That's why it's due 1 week prior to the assignment, so that we can give you feedback to say, that's not going to work out too great, right? Or have you thought about this, right? And we're going to give you that kind of feedback on every single one of these drafts, right? You are expected to follow the IEEE template, which we give you. If you know LaTeX, we give you a LaTeX template. Otherwise, if you just use Word, we give you a Word LaTeX, or a Word template, excuse me, right? But otherwise, the project starts in about week 4 is when you're going to start on that, right? But again, for the first 3 weeks, it's all let's get familiar with Java here, and the first assignment is due in week 3, right? Collaboration is highly encouraged, except on that first assignment. So when we get to this project, you will be allowed to pair up if you want to. No threes or anything like that. But you can go ahead and pair up with one other person in the class and work in pairs. Even beyond that, you can discuss at a high level with other teams. Like, I got this exception, what does that mean? Right? You can ask somebody that, that's perfectly fine. They can help you rethink your design. If you've got something up on a whiteboard, they can say, well, have you thought about, we didn't do it that way, we did it this way. And then you can have a discussion about that, right? High level, abstract discussions are fine. However, if you do choose to work, you can always work alone, by the way. That's perfectly fine. If you do choose to work in a pair, it has to be equal work. It can't just be you do the even phases and I'll do the odd phases. You know, you're not learning half the material that way. It can't just be, all right, well, yeah, I can probably work on Tuesdays, but I can't work any of those other days, right? And then you end up doing all the work and your partner just mooches off of you. Don't let that happen. Likewise, don't be the moocher, right? That kind of partnership probably needs to be dissolved as soon as possible, right? But why would you want to do this? It's easy to bounce ideas off of each other. It gives you an opportunity to develop those so-called soft skills, where you have to communicate, you have to collaborate, both electronically and in person, right? Teamwork and ultimately conflict resolution, because again, if you're doing all the work and your partner is not doing anything, right, you're going to have to approach them and say, look, you haven't done a lot. These are my expectations for fixing this partnership here, right? Again, partners can mooch. They can flake out. They can disappear. So if you choose to work in a pair, that means that you're responsible for yourself and that other person now, right? So make sure that you are committing to that idea. Right? Don't undermine the learning process of your partner. Don't undermine your own learning process by being the mooch or being mooched on, right? And of course, you should be using Git. In the first assignment, or in the first lab, we'll show you how to clone stuff, and then I've got a video on how to collaborate using Git if you choose to work in a pair. And any use of AI tools like ChatGPT or whatever, or Copilot, is prohibited. Right? It's got to be your own work. Take the long view for this course. Right? Today is the first day of the next 15 weeks, 15 weeks not counting the spring break. Right? Have a start early, right? In fact, to get you started, I'm going to show you a tool that you can use if you want to, or you can ignore it if you want to. If you're good, well self-disciplined, you don't need to use it. But if you're not well self-disciplined, then I encourage you to use it. It's called a Gantt chart. Make sure that you have a thought-out design on paper, right? In other words, your design document, before you even start coding, right? Sketch something out. In fact, that's all we're expecting in your design documents are sketches, right? We're not expecting full diagrams, UML diagrams, or ER diagrams. We'll talk about those later. But we're expecting sketches so that we can give you feedback on it, right? Design your test cases before you code, right? That's called test-driven development. What is a proper input and what is a proper output? Now I can start coding, right? Because if I just have an input and I start coding and I've got a solution and I run it through my solution and I get an output, how the hell do I know that that's correct or not, right? Oh yeah, it looks correct to me, right? No, you have to determine if it's correct before you start coding, before you run that test. Use proper debugging techniques. I'll demonstrate the debugger in Eclipse here momentarily, or maybe this week sometime. And remember the mantra that smart data structures and dumb code are a lot better than the other way around. What data structures can you use so that you can save yourself writing 100 lines of code? Right? Think like that, because that's what programmers do. They like to be lazy, right? What can I pull off the shelf to solve this problem? In fact, in my CS1 courses, I say, what's the number one question of design? If you approach your problem, what's the first question you should ask yourself? Is it already solved? And if so, just use that solution, right? In other words, how do I compute the square root? Oh, okay, I'll pull out my numerical analysis textbook and see that there's the Babylonian method. Oh, okay, I'll go ahead and start writing that out. No, the standard math library has a square root function. Use it, right? Beware of technical debt. If you don't have time to do it right the first time, then you're gonna have to find time to do it over, right? Technical debt is an idea that if you do something quickly, right, just throw something together, you are basically taking out a loan on your future self, your future self's time. Because if you didn't invest the time up front to do it right the first time, then you're going to be fighting that design later on, right? In other words, you've taken out, yeah, I did it quickly, I got it done at the last possible minute, but that means 2 weeks from now, I'm going to be fighting this bug and putting in 5 additional hours later on. Where if I took 1 hour of thinking and 1 hour of design this week, then I wouldn't have to take out that loan 5 hours 2 weeks from now, right? Think of your time as an asset that can either be invested or loaned and paid back with interest. So keep that in mind. Ask questions, attend help hours, and come early, right? Or start early. There are a whole bunch of resources for this course. The first one I want to show you, I'm going to start at the bottom here, is that Gantt chart that I was talking about. So this is available on Canvas on the first day here. I'll show you the links and everything. But otherwise, a Gantt chart is a project management and planning thing that has been around for more than 100 years. Basically, the idea is that you look at a deadline and say, I've got to have this done by a certain date. Okay, I know that it's going to take me this long to do. I'll estimate. It's going to take me 2 days to do that. It's going to take me 3 days to do that. It's going to take me 4 days to do that. And you see if you have enough time. You work backwards from the deadline, right? And that's what this is doing right here, right? Well, we've already started on the 20th, and there's the 21st. But reading and understanding the assignment for the first assignment handout, that's what you should be doing over the first 3 days. We're already in the second day here, right? But over the next 2 days, you should read and understand the handout. When you're done with it, you should mark it down. Oh, okay, I read the first 2 and I understand those and I know how to get started on that. Mark it as 50% done. Right? Or once you're done completely, mark it as 100% done. Right? Oops, 100%. There we go. And you see what happened with that nice magic Excel file, right? I know that I'm on track. Here is today. It's highlighted in red. Right? Am I behind or am I ahead? Right? If I'm already done with lab 1 by the end of the day, I'm going to mark that 100% too. Look at that. I'm already a day ahead. Right? So now I'm going to go ahead and start working on the next phase of my project, which is setting up my programs, like my Eclipse and stuff like that, for the programs. Right? Once I've done with that, I'll mark that 100%. I don't expect you to work on weekends because I barely work on the weekends. Right? So in this Gantt chart, I've grayed out all the weekends. But by next week, what you should start doing is designing your test cases. Right? Once you're done with that, you mark that as 100%. Right? Undo, undo, undo. Right? You've got a nice clean start on this Gantt chart here. You can fill in your names if you want. It's not something that you're going to be handing in. Right? This is a tool to understand, am I ahead in this course? Am I behind in this course? Or am I right on time in this course? And of course, it could be different, right? You say, well, okay, it's not going to take me 3 days to do that. I'll only allocate 1 day to do that. You can go ahead and feel free to change the dates. Did you see what happened? Everything moves up, right? I'll undo that there. But these are my estimates on what a typical student might end up spending their time on in each one of these things. I spaced the work out. Right? If you are working at the last possible second on that one due date where you're turning in assignment 1 and you're doing everything that's outlined here and you're trying to do it in 24 hours, it ain't gonna work. Right? So this is a nice way of spreading the work out. Okay? It's a Gantt chart. And here's assignment 1, assignment 2, and then I leave the rest of them blank for you so that you can start filling them out after you know how you work in the first couple of iterations. Right? That's a nice little Gantt chart, right? And it's over 100 years old. It is still used to this day in project management. Has anybody heard of it before? No? Okay. This is one of those tools that you'll learn then. Right? I'll just keep that off to the side for now. All right. Syllabus and policies are going to be on Canvas here. So there's that Gantt chart that I just showed you. You can download it and use it in Excel. Otherwise, here's the syllabus. Learning objectives, talked briefly about that. Tentative topics, we talked briefly about that. University services, if you have accessibility accommodations, please make sure they go through that process now. Otherwise, everything is live streamed through YouTube. So if we had a weather day or whatever they call it, a remote day, I might still live stream from home instead. Right? Otherwise, there are your labs, 350 points. Assignments, 950 points for 1,300 points, whatever that comes out to. Standard scale, A through F with pluses and minuses available. Lab attendance, assignments, grading policy, late work policy. Generally, there's no late work accepted. Okay, so make sure that you are handing stuff in on time. You can hand stuff in as many times as you want and run the grader and know that everything is correct as many times as you want up until that due date. If you've already done lab 1, I've demonstrated that in the first video there. If not, then that's what you'll get started on today. Okay. Academic integrity, use of AI, band, right? And the best way to get to communicate with me is through CampusWire. Right? So I've already posted, and if you have not accepted your invite yet, make sure that you do so. But otherwise, let's go to the UNO one here. Right? Every week I post a retrospective at the end of the week. At the beginning of every week, I post what we're going to be doing that week. So for example, your first lab 1, linked right there, is due this Thursday, 23rd by midnight. Okay, that's all you have to do this week. Next week, you'll have lab 2, the subsequent week, lab 3, and assignment 1. All of those can be found here. Right? There's assignment 1 that's due on Friday, Cinderella due date, so midnight, everything is midnight, 1 second before midnight. Everything is, so that one will be due Friday, February 7th, right, for assignment 1. These are the course topics here. There are the labs, 1, 2, and 3, all based on Java. Right? Ignore the Python, that's for a different section. There are my first 3 videos on getting started with this course. One of them is a complete walkthrough of lab 1. Right? So if you get stuck, we're here to help you during lab, but otherwise you can go ahead and watch that video for lab 1. Right? Otherwise, everything is separated by modules. Then we'll move on to OOP, object-oriented programming, databases, SQL. There's your spring break in March after week 8. List-based data structures, algorithm analysis, and then tree and tree-based data structures, all the way through the end of the semester. All the assignments are posted. All of the labs are posted. Right? You can work ahead if you want. That's fine too. Right? Let's see. There's a course FAQ, frequently asked question, if you want. Here's getting help. You're getting help at the lab times. We do have 3 TAs Sophia, Meng, and Zheng, I think. And you'll meet them all in today. Oh, you'll meet them all this week at various points in the lab sections. I haven't put their information up here yet because we have not determined what their help hours will be. I should also take that part out and that part because it doesn't apply to UNO. But there I am, right? My help hours, I'm going to have to take that out too because that's in Lincoln. I go back and forth. Tuesdays, Thursdays, I'm here at UNO. Monday, Wednesday, Friday, I'm down in Lincoln, UNO. Otherwise, all the assignments are there as well. Again, all you have to do is click directly on this. There's the handout, and there are the starting files. All right, so the handout looks something like this. It's all hosted on GitHub. The first assignment here, first exercise of the first assignment is a basic I/O program, where you have to read in, 3 points, and then you have to determine which of those 3 points are the closest using the Euclidean distance law here. The next one is your elevation utilities. So given this kind of map that looks like this, you need to convert it to meters, right? It looks something like this. So pretty simple, but then in the exercise 3, that's going to be the big one, right? You are given a bunch of running data with latitude and longitude, elevation, and time, right? And you have to produce an elevation report. What's the highest elevation? What's the lowest elevation? What's the elevation gain? As I was running, this is all my personal data too. So when it gets warmer, I'll invite you to run with School of Computing or whatever. But the elevation gain on that particular run was 185 meters, right? Now, elevation run is defined as going up. So if you're going down, that does not, down in elevation, that doesn't count towards your elevation gain, right? Then a distance report, right? How far did you run? 16.89 kilometers, about 10 miles. Your moving time, your waiting time, and then your total time. You have to produce a report that says all of these things. And then finally, data anomalies. There are going to be 2 sets of data, and you have to find the differences between those 2 sets of data. Right? That's going to be due in about 3 weeks here. Okay? All right. So that is Canvas, Campus Wire, GitHub, of course, which is the ultimate landing spot. Anytime you click on one of these links, you're going to be taken to GitHub. Otherwise, there's the course webpage is Canvas. YouTube. Right? So when I'm done with today's lecture, I will go ahead and update this at some point and put in a link here to the recording on YouTube. Right? Otherwise, the live stream is at my address here. There we are. And you can see that we are live right now. We can play it if we want to, but it's going to be a 10-second delay or something. All right. All right, so any questions so far? Yeah.
Do you have previous years of live streams still up?
Yeah, if you go to GitHub page for this, for the landing page, if you go all the way down, there are archived offerings there, and all the way back to 19. So there you go. 19, 20, 21, 22, 23, 24, now 25. So 7 years. I never repeat assignments, so I mean, I'm not. There aren't assignment solutions there if that's what you're looking for. All right, so let's see what else is here. Yep, all those resources. We'll talk about grading, how grading will work, and everything. I post everything on Campus Wire here. Okay. Otherwise, let's go ahead and get started. That was only, what, a half hour? So for our next, yeah, go ahead, sorry. Oh, yeah, so I don't have anything for the first module here, but when you get to the second module, I know I don't have it for the second module either, but here we go, Computer Science 2. It's not something you pay for. Let me go ahead and click on it and show you what it looks like here. It's on Bitbucket. Yeah, all right, fine. You can't display PDFs apparently, but I can show you what it looks like over here. So it's a free textbook, and I planned on eventually doing object-oriented programming, but you can see that there's nothing there yet, right? So, but when we get to, it'll be more relevant when we eventually get to databases. There we go. 50 pages of database information there. Right? including here's some data, right? That's what's called a flat file. It's basically a CSV file. How do we make that into, there's a lot of problems with that. How do we make that into a relational database? Right? So yeah, lots of text, lots of examples, whatever. There's the textbook for it. It's not something you pay for. It's just that when we get to it, here's the required reading, Computer Science 2, Chapter 3. Is that Chapter 3? It doesn't matter. Probably, yeah. Is it Chapter 3? What did I? Yeah, it is. Okay, Chapter 1 is just an introduction, right? Which I have not written yet. But when we get to databases and beyond, then all of these will have chapters to go along with it. Okay. There's other required reading, isn't there? The syllabus and the Gantt chart, of course. So in addition to the live streams from the last 7 years or whatever it was, I also have pre-prepared videos. So for example, there are, this is the playlist for this course. There's Lab 1 walkthrough, 0.1. If you want to get started on Java, I have like, 13 videos on getting started with Java. They're all relatively short, 17, 15 minutes long, right? All the way down to, this is what we're going to be doing in the first 3 weeks in class. But of course, you can watch these videos to get different examples, a different perspective, stuff like that. And then there's ranked, there's 3 exercises I do here at the end. Right? So, and then I don't have one on OOP, but that's where a lecture comes in. But then I have videos on databases, lists and list-based data structures, algorithms, algorithm analysis, and trees and tree-based data structures. So I've got most of it covered either by a textbook or by pre-prepared videos. All right, so once you've installed Java, once you've installed Eclipse, if you want to use something else, by the way, that's perfectly fine. If you want to use VS Code or you want to use IntelliJ or something like that, that's perfectly fine, I don't care. But you will have to figure out how to build your project and how to clone stuff on your own because I don't have information on those. The reason I use Eclipse is because it is free, right? And IntelliJ is like $100 a month now. Right? For students, it's free, yeah. VS Code, it's kind of free, but I mean, it's not really meant for Java anyway, but Eclipse is. Here's Eclipse when you start out, right? So just a welcome landing page. Right? We're gonna go ahead and close that. And I'm going to go ahead and create a new project here. Right? So let's see, create, new, and we're just going to do a Java project. Where is it? Project ... and then you can search around for, there's Java project, right? It supports a whole bunch of different types of projects. We're just doing plain old Java here. Next. I'm going to go ahead and call my project ECEN 156 because that's the name of the course. Right? You'll probably want to name it something more descriptive like assignment 1. And then when you do your project, you'll want to name it after whatever the project is called this year. I think it's a very good building company. The basic outline changes, it stays the same every year, but the client, it's a made up client. The client changes every year. Last year it was like a cell phone company. This year it is a construction management company that you're writing software for. Right? Otherwise, use the latest version of Java if you would, Java 21. I think that the grader is up on that. Another thing that you'll want to do, and this is in the instructions, is make sure that you off-click this. This create Java module. Java modules are something that were introduced several years ago. They're more of a headache than anything else, at least while we're starting out here. Next, right, and finish. And open that perspective, yeah, sure. All right, so here's my IDE, an integrated development environment. If you were using MATLAB, MATLAB is its own development environment. If you were using C last semester, what were you using? Probably code spaces, VS Code in the browser? Okay, something like that. Same basic setup here. Here are my files off to the side. Here's my editor here. I don't have anything open yet. And here I've got a bunch of other things that may or may not be relevant. Those two things aren't relevant to me yet, so I'll go ahead and close those. Right? Let me go ahead and create first what's called a package. A package is nothing more than, and here I'll do unl.ece because we're technically at UNL. Let's do UNL, right? We're at UNL. Right? And then you are in what department right now? The ECE department, right? So I'm going to go ahead and finish that. Now we've got this package here. What is that package? Let me go to properties, and I'm going to open it up on my computer here. Right? All I've done on my computer is in my source folder. Here's my project folder. In my source SRC folder, it has created a subfolder called UNO, and in that it's got a subfolder called ECE. In other words, it's just a bunch of folders. This is how we organize code over here in packages. Right? So that you can put stuff that's related to math in one package. You can put stuff that is related to, I don't know, business logic in another package. Stuff that's related to EDI in another package. Right? It's a way of organizing stuff. Right? I'm now going to create a new class. In Java, Java is a class-based object-oriented programming language, meaning that everything is a class or belongs to a class. That's my starting point. Right? And I'm also going to select this here because I want it to have a main. Right? What should I call this? Just call this Hello World. Anytime you pick up a new programming language, what is the first program you do? Hello World. All it's going to do is print out Hello World. Why? Because you want to make sure that your environment is set up, your compiler is working, and that you can actually see output. That is the, have you ever heard of MVC? MVP, not most valuable player, but minimum viable product, right? You just want the minimum viable program, if P in this case, in order to test your environment. Let's go ahead and finish this up. There we go. You can increase the size of your text if you want to, Command plus, or maybe it's Control plus, or what is it? Control plus on a Windows machine, plus and minus. Right? I'll try to make it as big as possible so that you can all see it. Right? But otherwise, make it as big as you want. Okay. Now all I'm going to do is I'm going to say system.out.println hello world with an exclamation point there. Some of this should look familiar, especially if you're coming from a C background. In a C program, where does your program start? What function do you have to write in order to make an executable program in C? The main, right? There's your main, right? Now, public, static, void. Well, public and static, those are probably new keywords to you. We'll talk about those later on. Very briefly here, public means that any code can see it. Static means that it belongs to the class. Void, you've probably seen that keyword before though. What does void mean in any programming language? Nothing, right? So if you had a void function, it returns nothing. Otherwise, if it was an integer function, it would have to return an int, return 10, if you spell it right. There we go. That's not what a main is. A main is a void function. It does not return anything. Now in C, you probably used argv, argc, argument vector and argument count. Those are the same. Those are in one here in Java. These are the arguments to your program. We'll do that. We'll go into that in detail later on. Instead of system.out.println, you probably did something like this: printf hello world, right? And then end the line there. Right? You can also do that in Java. If you go system.out instead, printf. There we go. So in other words, we've got the same output functionality in both languages. C, you use double quotes for a string, probably MATLAB too. Otherwise, MATLAB, you might be able to use single quotes as well. You can go back and forth, use either one. Right? But otherwise, it's very, very C-like. Why is that? Because when Gosling, or whatever his name is, designed the Java programming language, one of his design principles was it has to look familiar. He adopted C-style syntax for this. You see the same thing in C++, C#, right? The C-style syntax languages. Right? Even in PHP, not so much Python. What else is there? C#, I think I mentioned that, but whatever. Right? But instead of printf, we have this thing called system. dot out. That's the standard output. The standard output with C is just printf. Right? We also have println instead of printf. What do you think the difference is? What do you think ln stands for here? Line. Right? So instead of having to explicitly say end line, same end line character here, I can go ahead and just use println, and it'll put the end line character in it for me. Now that this is, if there was a problem, like for example, I misspelled or pint ln, right? It's going to highlight it with a red mark, right? It's not going to be compilable here, and if you hover over it, it's going to ask you, this method pint_ln is undeclared for the type print stream, and it's going to give you some helpful suggestions. This is not AI, right? This is just your IDE, right? Should I change this to println? Yeah, that's what I meant. Right, there we go. It did it for me. Okay. Now, how do I run this program now that it compiles? Right, there's no red there. Right. Now that it compiles, how do I run this program? This thing up here, the play button. There. And now down here in the console, I've got my hello world. Okay. Let's take a look at the directory structure again. There's my hello world.java source file. Right. There is a bin over here. Bin is not like a garbage bin. Bin is short for binary. In other words, in the background, my Eclipse IDE here was taking this code, compiling it to what's called a .class file. Right? And that's a Java source file. It's Java bytecode, which can run in a Java virtual machine. Your IDE over here makes all that opaque. You don't have to worry about any of that. You don't have to manually compile. You don't have to then say, well, compile it to this directory over here. Now run it. I have to do all that stuff because I do everything from the command line when I grade stuff. But I take care of all that for you. You don't have to worry about it. It's just a simple play button. Play, and it's done. You make a change to it. Hello world, emphasize that. Right? You have to save it. VS Code, folks, the VS in the code in the browser, code spaces is what you probably use. There's auto save every single time. Not something here. Right? I think you can set that up. Auto save. Nope, there's no auto save. There's build automatically, but otherwise you have to actually save the file. Right? Once you've done that, then you can run it. Right? Okay. But if I change it without saving it, it's simply going to run. Oh, do you want to save? Right? Yes, okay. And then it'll run the new one. Right? So as many changes as you want there. Okay? This is still not complete. Hopefully you got into the good habit of writing documentation. Let's write some documentation over here. The minimum documentation that we're looking for in the first few phases, or the first assignment here, is you got to put your name on it. Right? So there's my name. Right? Maybe the date, 2025-01, getting used to the new year here, 21st of January, right? And then the purpose of the program, a basic hello world program. That's what we're looking for. Name, date, purpose. That's it for now, right? Later on, when we actually have non-trivial functions, non-trivial methods, you'll document those as well. But you got to have your name on it, right? Just like an English paper. You've got the header of a date, your name, the class, whatever else they require you to put up there. And then, of course, the purpose here. Notice how I did that there, though? I didn't type all those stars, did I? Let me go ahead and take that away. What did I do? I typed the /*, and then I hit Enter. And it started code formatting that for me. Right? That's my IDE doing it for me. Let me go ahead and put that back. Why would you like something like this? This is called doc-style comments. Why would you like something like this? Because you can embed more information here. So for example, for the history of Hello World, world C, ahref, what did I just type there? Here. What is that stuff, gobbledygook that I just typed there? Anybody know? Oh, it's HTML, right? So hello world, let's see, Wikipedia. I'm sure that they've got an article on it because hello world program. There we go. And then I can embed that right here. All right. Now, why is that good? Because if I hover over this, do you see what it looks like? A basic hello world program, see here. It looks like it's clickable, and it is. Right? And if I click it, it takes me there. Right? So doc style comments are great because you can generate automatically documentation. Right? For example, the entire Java docs, if you search for, I don't know, Java string, the very first thing to come up is their documentation, the Java docs, Java documentation. Do you think somebody actually wrote, somebody did write this, but do you think that they wrote the HTML for this web page? Nope. They embedded it in the code. Right? Then they ran a tool to take all that embedded documentation and produce this web page. They could write it, run it to produce a PDF file. They could run it to produce a Word file. Right? They have to write once and then convert it to whatever else. And that's the beauty of doc-style comments here. If you want it to be more fancy, of course, you can embed other HTML stuff like headers, paragraphs, and that paragraph. And let's do H2 here. Right? That's header level 2. Right? And then this would be a paragraph. And then let's end that paragraph. And then another paragraph down there. Let's hover over this and look at, oh wow, that looks even better. Right? You don't have to get too fancy. You don't have to write actual HTML here. I'm just showing you this is the idea of using doc-style comments. Every language supports something like this because every language has a tool to do something like this. Right? Doc-style comments. That's what we're looking for when we look for comments, because when you actually have to, let's see, where's our assignment 1? I thought I left it up, but I didn't. Did I? Oh, no, here's assignment 1. How do we grade? We grade based on style. Appropriate variable names, function names, good use of white space with proper indentation, clean, readable code, documentation, well-written comments that clearly describe what any non-trivial piece of code does. They're not overly verbose, not overly terse, right? Code itself should be self-documenting. What I mean by that is you shouldn't have something like this. Prints out hello world to the standard output. This is bad documentation because once you've learned Java, you will know system.out.println, that prints to the standard output. What does it print? I know what the string is. It prints hello world. This line of code is self-documenting. Having that is duplication, and we hate duplication. Right? We like things to be in one place. DRY, the DRY principle. Right? If you've never heard of that, it's DRY, don't repeat yourself. Right? So duplication, no. Superfluous comments, no. Good white space, yes. This is bad white space. In fact, if I just eliminate, or maybe I do one space here, and I end up spacing over there, and then, I don't know, space, 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 everywhere. Put that beginning there, but then I have this one beginning on that line. Right? That is terrible white spacing. That will be definitely points off. Fix it with one keystroke. Right? Oops, sorry. Right, there we go. What I just did was Shift Command F. I'm on a Mac though, so on a Windows machine it'd probably be Control Shift F. F stands for format, and it'll automatically format it in the proper Java formatting. Right? So I mean, if you just start typing well enough, it'll automatically indent for you. System.out.println. Goodbye, world. There we go. Okay. What other similarities do you notice about C, from C? Or maybe from MATLAB? I already mentioned that this thing, what? Double quotes are used for strings. Right? What about that thing right there? Semicolon at the end of every executable line, just like C, right? And MATLAB? Yeah. Okay, right. Why? Because, well, it's the same reason we put periods at the end of sentences. How do you know if you didn't have any periods or exclamation points or question marks, right? Everything would just be a wall of words, right? We don't like that, okay? We like punctuation here. Opening brackets and closing curly brackets, right? They denote code blocks. This is a code block right here. Over here in your IDE, you can actually collapse it and expand it if you don't want to look at it. Here is another code block that belongs to the entire class. If I were, we're not there yet, but if I were to write another function, public, static, int, add, int A, int B, right? Oops. return A plus B. Never write a function like that, right? You've just done 3 lines, what should have been done in 1 line instead, right? But there is a function, right? If, let's see, where was I going? Oh yeah, that's another code block. That is collapsible as well. Opening curly bracket, ending curly bracket. We've got basic math here as well, okay? I'll go ahead and get rid of that because it's a bad function. Now, well, actually, let me restore it here for a second. And let me go ahead and add documentation to that function. You see what that just generated? Parameter, parameter, and its return value. The first value. The second value. The sum of the 2 values. Right? And I can say this method or function computes the sum of 2 values. There we go. Actually no, I'm going to have to use code A, code, and code B, code. That's HTML. Right? Let me show you what it looks like. Right? So this method function computes the sum of 2 values A and B. It's kind of difficult to see, and I can't zoom in on that. But you see that A and B are in monotype font because I denoted them as code. Right? What else was there? Yeah. That's it, right? But otherwise, everything is nicely formatted if you're using doc style comments here. Okay. So let's talk about the basics of Java here. As I've already said, Java is a class-based programming, object-oriented programming language. What that simply means is that everything is a class or belongs to a class. Right? By the way, I do not use PowerPoint. All of these notes are typed or copied over as we go along, and all of these notes will be committed to GitHub. I'll put the link at the end of the week here, or later today. Right? And what are classes? Classes are simply units of code that are declared with their own source file. Remember over here, we called our class helloworld.java. When that got compiled, it got compiled into helloworld.class. Those names have to match. If they don't match, this is a helloworld.java file up here, but if I say goodbye world, it will no longer compile because the names don't match. If I misspell it, hello world, and casing is misspelling, right? Casing matters. That is also not going to compile. It's got to be uppercase H. And in fact, with all of our, with all of our classes, it's going to be upper camel cased, right? So style, all classes are upper camel cased. Let me give myself some more room here so that it snaps up. There we go. Okay. Upper camel case. That means that the first letter of each word is uppercase, all the rest are lowercase. That is a Java invariant, right? It's not a requirement, but it is a Java style, right? Okay. Source files are compiled into a Java virtual machine code, that .class file. If I were to open that up, let's try opening it up. Open with, I don't know. Okay, I'm not going to have any choices there. Here's my IDE. Try to drag it over here. Try to open it up there. There we go. Some of it is going to be readable, but the vast majority of it is not going to be readable because it has been compiled to Java bytecode. Okay? This is the only thing that is readable here. It was compiled for Java 21, right? The actual version is 65. That's the official version. And then a whole bunch of, not intended for human consumption directives here that are directives to the Java virtual machine. The reason that it is compiled to Java bytecode is because Java has a write once, compile once, run anywhere, right? Philosophy. Java was actually a program that was created for, you probably, I don't know if you've ever seen them in your lifetimes, cable boxes, right? So to get cable, you actually had to have a box on the top of your TV set which decrypted or decoded the cable to make sure that you were a current subscriber. Well, some company wanted to have an actual programming language. It was before Roku and all this stuff. programming language to so that people could actually write content for it, games or whatever. And so they came up with Java. That never went anywhere, but Java as a language took off. The idea was, we're not going to write C code that compiles for one machine and can only be run on that one machine. We're going to write Java code that can be compiled for a Java virtual machine. That virtual machine can run on Windows. It can run on Linux. It can run on Mac. It can run on any operating system. Right? In other words, there's this layer of abstraction where we don't have to worry about the hardware details like you do in C. Right? Instead, we just write it once, compile it once, and anybody that has a Java virtual machine can run it. Right? That's why it's run anywhere. Write once, compile once, run anywhere. IDEs, like integrated development environments, integrated development environments, right? Like Eclipse can hide these details. In fact, they do. Right? Integrated development. Integrated. There we go. I won't always correct all my spellings, so sorry. Right? As we've already seen, classes are organized into packages, and these are just simply directories or folders. Okay? Packages provide organization for your classes. Now what I'm going to do is I'm going to go ahead and take this Hello World program, and usually I don't share code, I don't share the actual code. Instead, what I do is I embed the code into the notes here, right? And it'll look all once it's on GitHub, it'll look all pretty like that. Right? It's pretty as in color-coded markup. Right? Okay. So there's our first Hello World program. As we've said before, it is a C-style syntax. So semicolons at the end of every executable code. Curly brackets, opening and closing curly brackets, right? Dot, dot, dot. Right? Those indicate code blocks. We've already seen comments, right? But in more detail here, single line comments are going to be // Actually, is that a backslash or is that a /? And how do you know the difference? Those are /. Why? You read right to left. So if you're facing left, right, are you leaning forward or are you leaning back? That's how I remember it. Okay. You have multi-line comments, which are going to begin with a /* and end with a */. And then, of course, you have doc style comments, right, where it is /** and then a vertical line of stars and then a */. It's nothing more than a multi-line comment here, but it's for documentation. Author documentation, class documentation, method documentation, just like we did up here. There's the class documentation. There's the method documentation. I didn't put one on main because that's trivial. What does main do? It's the main. What would I write for it? I would just write the main method, right? That's what everybody, once you know Java, you know that that's the main starting point of any program, right? So I'm not going to put documentation. Documentation is for non-trivial functions. So like that add function that I made. Don't write that function. That's just an example to start out with, right? Okay. White space does not generally matter for the programming language, but it does matter for readability. Right? So make sure that you properly indent. You can fix formatting by using, what did I say, Shift, Command, F. Right? This is for Mac. For Windows, I have no idea. You inform me later on. Right? Okay. Double quotes denote strings. Right? Single quotes, what do you think that those denote? Single character values. Right? So I marked up char there. Why? In C, what do you have? In C, what are the basic variables that you can use? Int, char, float, double, right? All of those are in Java as well, right? But let's talk about the differences first. So in C, hopefully you had to use malloc at some point. Yes? And once you, that malloc allocates a chunk of memory so that you can use that memory. Once you're done with that memory, what do you do with it? Free. Malloc free. That's memory management. You have to keep track of the pointer to that memory. You have to keep track of how big it is if it's an array. And you have to make sure that you clean up after yourself. That's a difference. In Java, there is no memory management. Right? There is no malloc. There is no free. Instead, it's automated garbage collection. That's what it's called. Right? That Java will look at your memory and periodically say, nobody is using this memory anymore. I'm going to clean it up for you. Right? And it cleans it up automatically. Right? Unfortunately, you pay a price for that. There is no Java program that is going to be performant with respect to a C program. C programs are going to be orders of magnitude faster than Java programs. Right? And Java programs are going to be orders of magnitude faster than Python programs. Right? So as you add a layer of abstraction on top of C, you pay for that layer in performance. Okay? But it's portable. You write it once, you compile it once, you run it anywhere. And also it's backwards compatible. Right? To a fault, actually. Right? They will the Java folks have bent over backwards to ensure backwards compatibility, meaning that I could take a program that was written in 1995 and compiled in 1995, and I can still run it today. Right? C is kind of like that, in that they are very, very conservative in the changes that they make. The first C standard came out in 1979. The second one came out in 1989. The next one came out in 1999, right? Is there an 09? I think that there is. Basically every 10 years they add a new standard for C. Very, very little changes, right? Why? Because they're extremely conservative and they don't want stuff breaking, right? That's for the C++ folks. That's for the Python folks that don't make anything backwards compatible. This is why we have Python 2 and Python 3, because they realized all their mistakes. To fix them, we're not going to be able to make it backwards compatible. And that's why nobody uses Python 2 anymore. Right? So it's backwards compatible, possibly to a fault, and we'll see why it's to their fault later on. Right? All right. I already mentioned variables. Java supports int, right? Which is a 32-bit integer. Right? This is assigned 2's complement integer. Don't worry about that. Just worry about what the limitations are. The limitations are you can have up to 2.147 billion for a maximum and 2.147 billion negative for a minimum, and 0, of course. Doubles. Right. Our floating point numbers with 64 bits of precision. You did mention floats. There are floats, but I don't generally use them because they're neutered doubles, right? There are a few instances where you would want to use floats, game programming, right? Because you don't need 16 digits of accuracy to render 1 pixel. Right? You only need about 6 digits of accuracy to render a pixel. So there, it's a little bit more performant to use a float instead. Chars, yes, but why use them, right? You might, I mean, there are, maybe there's a reason to use a single character in Java. Very, very few. Right? Instead, use strings. All right, there we go. So notice how I highlighted that. String is the code, and then S, the plural of that, is not the code, right? So for example, let me come over here, and instead of printing out hello world here, let me put that into a variable. String S is equal to that. Can you do that in Java? Trick question, by the way. Well, okay, you can't. Can you do string in C, I should say? Nope. Instead, what would you have to do in C? Yeah, character array. Can't do that in Java. Right? Instead, Java, we can afford a string. Right? Because in C, it's null terminated, right? And it has to be null terminated, and you have to do memory management, make sure that it's big enough to hold hello world and the null terminating character, et cetera, et cetera. You don't have to do any of that here. It's just a string. A string is a string is a string. And now instead of printing out hello world, I can print out S instead. And it'll have the same behavior here. Okay? So use strings instead. Right? Even one character, like an initial or something like that, string initial, my initial, I can do something like that. Right? It's just a string of length 1. Okay. So why use regular old chars, right? Java has truncation with integer division, just like C. I think MATLAB is probably like this too. Let me go ahead and create a brand new, I don't want to keep messing around with our hello world there. So let's go ahead and create a brand new demo class here where I will put a bunch of code, public static void main string args. Right? So let me go ahead and create two integers here. Int a is equal to 10, int b is equal to 20, int c is equal to a divided by b. System.out.println c. What value is going to get printed? 0. Why? It's an integer. 10 divided by 20, it's 0.5. But the result has to be an integer. So when it's 0.5, what is the integer part of that? 0. 0.5, and the 0.5 does not get rounded up or down. It simply just gets cut off and thrown away. That is what truncation is. Let me get rid of this. Integer truncation. I'm not sure that you have this problem with MATLAB because it probably automatically marshals it into a floating point number. Right? Doesn't happen with Java, it doesn't happen with C, it doesn't happen with any C style language. Right? What happens is truncation. Right? So I'll go ahead and put this into the notes as well so that you've got it just in case. Actually, before we do that, what's the solution? Okay, so first of all, we need a double to hold it, right? Because integers cannot hold floating point numbers, fractional numbers. This is still not enough though, right? 0.0 because 0 became 0.0. So we do what? Cast it, double. Right? We have to do it to at least one of them. Right? And when I do that, yay, it worked. So let me restore int d is equal to, actually, double c is equal to a divided by b, and comment that this is prints 0.0 because of truncation. Right? This is typecasting. Typecasting corrects the issue. Right? This prints 0.5. Oops, there we go. Okay. So I'll put that chunk of code in your notes so that you have it if you want it. That'll of course be committed and available along with all the other notes. Right? Basic operators. Right? So how do you add stuff? Plus. How do you subtract stuff? Minus. How do you multiply stuff? Asterisk. How do you divide stuff? We just saw that. Is that a forward slash or backslash? Forward slash, right? And then you have integer or remainder division. Have you seen this one before? Percent. It's not a percent, it does what? It finds a remainder, right? Let's look at an example here. Let's go with int c is equal to a, we read this as mod b, right? So when you divide a by b, b goes into a how many times? 0. So what's the remainder? 10. Right? Let's do another example. Let's see. 10 divided by 7. 7 goes into 10 once, but what's the remainder? 3. Right? So this gives you the remainder. Gives the remainder of a divided by b. I'll put that above there. Okay. And do we want to see another example? So how could you probably use this? What if I divided by 2? 2 goes into 10 5 times with a remainder of 0. Okay. 2 goes into 9 4 times with a remainder of 1. So there's an easy way how you can tell something is even or odd. Right? Mod. Okay. And if you want it, let's go ahead and put that in there too. Need to mark it up as Java though. Oops, Java. Okay. Okay. What other operators are there? A new one, right? String concatenation, right? You can combine or concatenate two strings or a string and anything else using the plus operator. Okay? So if I've got two numbers, A plus B, A is a number, B is a number, you're going to interpret that as addition. But what if I had two strings instead? String A is equal to hello. All right, there we go. String B is equal to world. How can I combine those into an entire message? String message is equal to A plus, and I want a space in between them, plus B. Right? What would you have to do in C to do that? Yeah, what was that function called? str cat, concatenation, right? But what would you have to do before that? You'd have to make sure that there was enough memory to hold it. Then you would have to make sure that it was null terminated. Then you would have to copy over the first one and then concatenate the second one, then concatenate the third one, and cross your fingers and hope that that was still null terminated, right? Any problems there? Nope. It's all abstracted away. We don't have to worry about any of that. And by the way, once you're all done, would you have to free each one of those strings because you allocated them using malloc? In C you would, here you don't. Right? So there's our full message, hello world. Right? And it's the string concatenation operator, okay? You can use it with anything. Int x is equal to 42. Message is hello world plus and x is equal to concatenate with x. Right? This thing is a string plus something that is not a string. What happens is that thing that's not a string is automatically converted into a string for you so that it concatenates into a one big giant string. And by the way, you can still have printf formatted styles. So int, or let's go with double y is equal to 3.14159. Yeah, that's good. And system.out.printf. Let's go ahead and use the printf style formatting. X is equal to %f for a floating point number. That should be y, right? Y. And then x is equal to, what is my placeholder in printf for an integer? D. And then end the line. And then I want y and d, or x, sorry. Works. Printf style, you just have to prepend system.out. In fact, it's even better than the C printf, because if you do something like, let's go with z is equal to %d, but I don't give it something that's an integer, I give it something like a message. Can a string be converted automatically into an integer? Nope. The what happens is an exception. This is error handling here. Illegal format conversion. D, %d, is not equal to a string. So I'm going to get an error message about that. If I did something like that in C, I would just get, garbage results. It'd do it. All right? It would give me garbage results. I'll go ahead and get rid of all of that. All right, that's about all that I wanted to cover today. Instead, in your lab today and Thursday, you'll just simply get set up with Eclipse. You'll walk through some basics, reformat stuff. It walks you through it 100%. You'll go through the hand-in process. If it doesn't, if it doesn't pass everything, you'll go through the re-hand-in process. Then you'll go through the grading process, and I'll be there to help and to make sure that everybody has the accounts that they need to do so. Okay. All right, I'll see you up in PKI 313 in about 15 minutes then. Okay. And normally I have like a separate baffled microphone here, so your voices shouldn't be picked up if you have a question. So don't worry about being